So let's go ahead and determine the asymptotes for the four given rational functions. Good morning, everybody. So if I have f of x equals 2 over 3x plus 1, I want to go down the list, first checking for vertical, then horizontal, then oblique if necessary. So first, vertical asymptotes. We find all vertical asymptotes by setting the denominator equal to 0. So my vertical asymptote is going to be given by 3x plus 1 equals 0, and then I solve for x. So I get 3x equals negative 1. I divide both sides by 3. I get x equals negative 1/3. So for problem 1, I have a vertical asymptote at x equals negative 1/3. Next, I need to check for a horizontal asymptote. If the numerator has lesser degree than the denominator, the horizontal asymptote is y equals 0. Well, my numerator is degree 0 and my denominator is degree 1. So my numerator does have lesser degree than my denominator, so I have a horizontal asymptote at y equals 0. Notice, now you can stop, right? Because the next option is if the numerator and denominator have the same degree, and the option after that is if the numerator has a greater degree than my denominator, okay? So once you hit either A, B, or C, you can stop. So the answer for number 1 is it has two asymptotes. It has a vertical asymptote at x equals negative 1/3 and a horizontal asymptote at y equals 0. Let's go ahead and check our problem 2, and we'll do problem 2 in green, and then I'll clear the space to give us some room. So the first thing I do to find my vertical asymptotes is I'm always going to set my denominator equal to 0. So that was too many dots. So my vertical asymptotes, 4x minus 1 times x plus 5 equals 0. And that's just so nice because it's already factored for us. So I'm going to go ahead and take 4x minus 1 equals 0 and x plus 5 equals 0. I then go ahead and solve for x. I add 1 to both sides. I get 4x equals 1, so x equals 1/4. I subtract 5 from both sides, so x equals negative 5th. So I have two vertical asymptotes at x equals 1/4 and x equals negative 5. I then look to find my other asymptotes. If the numerator has lesser degree than the denominator, then there is a horizontal asymptote at y equals 0. Here my degree of my numerator is 1. And if I was to FOIL this out, the degree of my denominator is 2. So I have a horizontal asymptote. I don't know why I'm doing a colon. I mean to do like a period. At y equals 0. So this first example had two asymptotes, and this second example had 3. 2 vertical and 1 horizontal. All right, I'm going to go ahead and clear the space, and let's take a look at number 3. So the first thing I do to find my vertical asymptotes is I set my denominator equal to 0. I add 6 to both sides. I get 4x equals 6. I divide both sides by 4. I get x equals 6/4, which we would simplify down to 3/2. So I have one vertical asymptote at x equals 3/2. Now we go looking for our other asymptotes. If the numerator has lesser degree than the denominator, then there's a horizontal asymptote at y equals 0. Well, the degree of my numerator is 1, and the degree of my denominator is 1. So they don't meet the criteria for A. I look at B. If the numerator and denominator have the same degree, which mine do, then the horizontal asymptote is y equals the leading coefficients as over each other as a ratio. So I have a horizontal asymptote at y equals 2/4, which is y equals 1/2. So I have a vertical asymptote at x equals 3/2 and a horizontal asymptote at y equals 1/2 because it met the criteria for B. I'm going to go ahead and clear this so we can do our final example. I have f of x equals x squared plus 1 over x minus 3. First thing I do is find my vertical asymptotes. That's always going to be the case. This never changes. I set my denominator equal to 0 and I solve for x. So I have a vertical asymptote at the line x equals 3. I then need to find my other possible asymptotes. And it really depends on the degree of our numerator and the degree of our denominator. So let's go ahead and label those. My numerator is degree 2. My denominator is degree 1. Okay, for A, if the numerator has lesser degree than the denominator, then there's a horizontal asymptote at y equals 0. Well, my numerator has greater degree than my denominator, so I don't meet the criteria for A. Let's go to B. If my numerator and denominator have the same degree, I have a horizontal asymptote of this form. Well, my numerator and denominator are not of the same degree, so I don't meet the criteria for B. Let's take a look at C. If the numerator is of degree exactly 1 more than the denominator, there will be an oblique slanted asymptote. To find it, I have to divide the numerator by the denominator and disregard the remainder and set the rest of the equation equal to y to obtain our oblique or linear asymptote. Well, my degree is 2 is exactly 1 greater than 1, so I have to take x squared plus 1 divided by x minus 3 in order to determine my oblique asymptote. Oblique. What do I multiply x by to make it look like x squared? The answer is x. X times x gives me x squared. X times negative 3 gives me a negative 3x. I subtract this. My x's cancel. 0x minus a negative 3x, that becomes a positive 3x, and I pull down my next term. What do I multiply x by to make it look like 3x? The answer is going to be 3. 3 times x gives me 3x. 3 times 3 gives me negative 9. I subtract this. 1 minus a negative 9 gives me a 10, but we disregard the remainder and set the rest of the quotient, that's this right here, x plus 3, equal to y. So I have an oblique asymptote at y equals x plus 3.